Hello everyone, today we're going to graph systems of linear inequalities, okay? Basically, the easiest way to describe this is you're going to graph two or more inequalities and you're going to see where the shadings overlap at. Try to not make it too hard, it's really not that bad. There's only two steps. You're going to graph each inequality just like we did yesterday, and then you're going to just shade them and see where do those shadings overlap at. And where they do overlap, that's going to be your answer. Okay, so take a minute, write these two down, pause the video if you need to, and then come back to it. Alright, so here is our first example. We're only going to do two examples because I think you guys can get this. It's not really that bad. So here's our first one. I'm going to put every single one of these in slope-intercept form because I hope by now you know how to change something into slope-intercept form. So our first one is y is less than 1/2 x minus 4. The second one is y is greater than or equal to negative x minus 3. Okay, if those were not in slope-intercept form, then that would be our first step. Change them into it, and then we would be able to graph it. Don't forget, if you ever divide by a negative, always flip the sign. Okay, so basically all you have to do is graph each one of these inequalities and then see where do those shadings overlap at. That's going to be your answer. So here we go. For the first one, y equals 1/2 x minus 4. So that means I'm going to start off at 4 on the y-axis, negative 4. So down right here. My slope is up 1 and over 2. Okay, and hopefully yours looks a little bit better, especially if you're using graph paper like you should. Okay, so it should look like that. This one you're probably saying, yeah, that one should be dashed. Okay, so put my arrows on it. And then hopefully you do the shortcut because that's a lot quicker. Since the y is on the left side, less than means shade below. So I'm going to shade down here. So it looks like that. Okay. The next one, I'm going to start off at negative 3 for the y-intercept. So down right here. Then the slope is down 1 over 1. Down 1 over 1. Or I could go up 1, left 1. Same thing. Just graph those. This one's actually going to be solid because it has the equal to on it. So there is my second line. And then the shading on this one would be above because it's greater than. So I'm going to shade all of this. So the blue one that was shaded below, this one was shaded above. Where the two shadings overlap, that is our answer. So actually, where I'm going to shade would be this area right here. That's my actual answer for this. And what that actually means is these points right here, those are the points where it's solutions to both of the linear inequalities. Okay? This area up here, well, that one only works for one. It works for this one, but it doesn't work for that one. This area down here, it works for the top one, but doesn't work for the bottom. This area over here, they don't work for either one. Okay? But our actual answer is this, the ones that work for both inequalities. Okay? So hopefully that kind of bugs you, because this doesn't look good at all. It looks kind of ugly. I might as well call this graph bin, because it's so ugly. So instead of doing it this way, I'm going to show you a little trick. Let me erase this really quick. Actually, I'll just start. So the first one again, we're going to start off at negative 4, put a point, up 1 and over 2. Okay, and then that one was the dashed line. Okay, I'm going to do this kind of fast, because I don't want the video to be too long. And it was below. So instead of actually doing the shading below, what I'm going to do is I'm just going to draw a little squiggly line right below it. And then that just lets me know, hey, I was shading below that line. And then for the next one, it is y is greater than or equal to negative x minus 3. So that same line, negative x means I go down 1 over 1. Okay, so it actually looks like this. And the line should be straight. Okay, I'm just trying to go too fast. greater than and above, instead of actually shading everything, I'm just going to do a little squiggly line. Once you get the hang of this, you can actually see where those are going to overlap. Like this one was shaded below, this one was shaded above. So my actual answer is still right here, but that looks a lot cleaner. And what you could do is you could erase the squiggly line that's right here, and then it makes it look a lot cleaner. That one actually looks good compared to the other one. The other one I think looks kind of ugly. Okay, let's try one more example. This one's actually going to have 3 inequalities instead of 2. So let's try that. Each one of these we can graph the way that it sits. And I'm out of the graph, so I'm going to go ahead and make them right here. So my first one is y is greater than or equal to 2. It's either horizontal or vertical. Hopefully you remember y equals, those are horizontal. So I'm going to go up 2 and make a vertical or a horizontal line. And this one was solid, so it's a horizontal line, looks like this. Okay, this one was shaded above, so what I'm going to do is I'm going to make the little squigglies right above it. One thing other people do is they put little tick marks. That's okay. Some people kind of mistake those for these tick marks though. So either one, it'll be fine. Second one, I'm going to start off at 7. And I didn't make my graph big enough, so bear with me. So there's 7, put a point. Down 4, right 3. So right here. And right here. And I'm going to connect those. That's another solid line. So it looks something like that. Hopefully yours is straighter because you use a ruler. Okay, this one I'm going to shade below. So then the squiggly line below. So far, it looks like this area right here, that's our shaded region, because this one was above, that one was below. This area only works for the second one, this area only works for the first, this area doesn't work for either one. Okay, the last one is one that people they don't really understand how to graph it. X is greater than or equal to 0. Well, if it's x equals, that means it's a vertical line, hopefully you remember that, at 0. So here's 0. It's going to be a vertical line. So it's actually just the y-axis. So you have to just draw it in again. And this says greater than. When you have a vertical line, the greater than or the bigger numbers are to the right. If it was less than, it would be going to the left. So this one, you're going to shade this way. Okay? So our final answer is actually this triangle right here in the middle. That's it. Okay? Don't get into the habit of always making it the bounded area. Sometimes it might be this area, it could be this area, it could be this area. It all depends on your signs right here. For example, if I were to change, let's just change this one. Instead of a less than, let's change that into a greater than. Well, now this was that line, instead of shading below, I would actually be shading above. Let's see how that changes my graph around a little bit. So I'm going to take out what I shaded before. And let's recheck this. Y is greater than or equal to 2. Well, that's above still, so it's still here. This one is now going to be above, so it's actually right there. X is greater than 0, still to the right. So instead, it's not going to be this triangle because this says a shade above, not shade below. So the region is actually all of this up here. That would be your answer. So it's basically this top right portion. It doesn't include this. Okay, that's going to be blank. It kind of goes up with the y-axis to the right, above this line, and above this line. So really, it's this area right here, that would be our answer. And that's the points where they work for all 3 of those inequalities. Okay? I don't have any for you to try before class. Basically, when you come in tomorrow, you'll get some problems, and we'll see if you guys understand this. See you tomorrow. And let me turn this off right